So let us first define the per unit method. The per unit value is defined as the actual value divided by the base value. Remember, this per unit value is defined as the actual value divided by the base value. Sometimes uh, in the questions it is written to get the value in percentage, so multiply the per unit value with 100. So remember this formula also, the per unit value into 100 equals to percentage value. Sometimes the percentage value will be given to you and you have to find out the per unit value. So divide the percentage value by 100 and you will get the per unit value. Remember the third point, the per unit value is a unitless quantity. The per unit value does not have any unit. This per unit value is a unitless quantity. It will not have any unit. So these are the three important points. The definition of the per unit value is the actual value divided by the base value, and the per unit value multiplied with 100 equal to the percentage value, and the per unit value is a unitless quantity. It does not have any unit. See the example 1 and example 2. In the first example, this is very simple example. Suppose the actual value of the voltage. The actual value of the voltage is given as 400 kilovolt and the base value is given to you as 100 kilovolt, and in the question he is asking the voltage value, the value of the voltage in per unit. So we know the definition that the per unit value equals to actual value. This is the actual value divided by the base value. So actual value divided by the base value will be 4 per unit here. Now see the second example. Here the actual value of the voltage is 400 kilovolt, the same as in example 1, but the base value is different here. In this example 2, the base value is 400 kilovolt. So the per unit value of the voltage will be the actual value divided by the base value. Actual value divided by the base value, so it is 1 per unit. Although the example 1 and example 2, they are very simple, but one thing must be noted here, that the actual value in example 1 and in the example 2 is same. The actual value is 400 kilovolt in example 1, and in example 2 the actual value is same as 400 kilovolt. In both the examples the actual value is same, but the base value is different. In example 1 the base value is 100 kilovolt, and in example 2 the base value is 400 kilovolt. Because of the different base values, the per unit value of the same quantity, of the same value of the quantity, the per unit value is different. If the base is different, for the same actual value, the per unit value will be different. Now see, in electrical engineering you will encounter with voltage, with current, with the power factor, with the real power, reactive power, apparent power, with resistance, reactance and impedance. So you will see these quantities. Out of these quantities, power factor cannot be represented in per unit. This power factor cannot be represented in per unit, but all these values can be represented in per unit. If you want to represent the per unit value of the voltage, you need a actual value of the voltage divided by the base value of the voltage. If you want to write the per unit value of the current, you need the actual value of the current divided by the base value of the current. If you want to write the per unit value of the power, you have to write the actual value of the real power divided by the base value of the power. As base, as means this S represent the apparent power. So always remember that while defining the per unit value of the power, write P actual divided by the S base. To write the per unit value of the reactive power, write Q actual value of the reactive power divided by S base. If you want to write the S, the reactive, this apparent power in per unit, you should know the actual value of the apparent power divided by the base value of the apparent power. See, if you want to write the resistance in per unit, the actual value of the resistance, the per unit value of the resistance will be equal to the actual value of the resistance divided by the base impedance. See, if you want to write the per unit value of the reactance, write the actual value of the reactance divided by the base impedance. See, if you want to write down the value of the per unit impedance, write the actual value of the impedance divided by the base impedance. So there may be question in your mind, why not you are writing the R per unit equals to R actual divided by R base. So the solution of this question is, see, the Z actual is written as R actual plus J X actual. To define the value of the Z per unit, you will write Z actual divided by Z base. So this Z actual can be written as R actual plus J X actual divided by Z base. So it will be RA upon ZB plus J XA upon XB. So this will be written as R per unit, R actual divided by Z base equals to R per unit plus J X actual upon Z base equals to X per unit. Remember this.